So far, I just give you some, just tell you a lot of bad news, just and in the crowd, and you are going to bump into a new kind of security threat, which you never expected. But right now, I'm going to give you some, just and good news. If you use cloud right, you might be able to, find just a more effective solution to some old, long-standing security problem. So the problem I'm talking about is, just DNA alignment, secure DNA alignment. Hope, just this part a little bit dense, I don't hope, I don't want to make you guys sleepy. Okay, so here's the story. Genomic revolution is something and one very exciting things, we witness. And in the near future, there's chance all our DNA sequence will be extracted, right, attached to our medical record. Why? And because looking at your DNA record, your physician, your doctor can give you a personalized therapy, personalized treatment, right? And a lot of things are different. Just an example is cancer. Although two people can have the same type of cancer, but the cancer itself could be very different. And one person, the treatment to one person could be completely different to the second person, just because the genetic structure is different. So if we can have this DNA sequence attached to your medical record, right? It will make make all this disease treatment therapy more effective, right? So here are the good things, and this is completely feasible in a few years to come, because today the cost of sequencing becomes so cheap. Actually sequencing power double every 5 months, while computing power double every 18 months, right? So the cost for whole genome sequencing quickly goes down. I think in a few years it will drop below $1,000. So a lot of people can have your DNA sequence extracted. But the problem here is, after you extract DNA sequence, you need the computing power to process it, particularly in these settings. And what a sequencer can give to you is not your whole sequence, which including 6 billion nucleotides. Instead, what it can give to you is a lot of short sequence, about 10 million or more short sequence, each contain 100 to 120 nucleotides, right? If I give you a load of short sequence, you can make no use of it. Why? Because you don't know their position, right? So you have to find out the location of the individual sequence so that you can reconstruct the whole 6 billion long sequence, right? So the whole thing is just like solving a puzzle, right? You have to put each piece back to its right position. Right? The simplest way to do that is using a technique which we call read mapping. That is, you have a huge reference genome which contains 6 billion nucleotides, donated by someone old enough and rich enough and who can afford to forget about his privacy, right? And using this reference genome, you can take advantage of the fact that humans, are very similar. You pick up anyone, just in this room. No, I'm talking about this 10 room, scattered across the country, right? Any 2 persons, and I guarantee you, the difference of you guys' DNA, just will below 0.5%. 0.5%. It's very, very small, right? So by taking advantage of this fact, what you can do here is you can try to align, this short sequence to the reference genome, right, one by one, until the short sequence has hit the part that looks like very similar to the short sequence. In this particular case, this short sequence has been aligned to another subsequence on the reference genome, right? These two things look very similar. Only difference is one nucleotide, C, has been changed to T, right? So when this happens, you can see maybe this short sequence belongs to this place, right? So you do it one by one. Ultimately, you can put all these 10 million short sequences back to the right place to reconstruct at least part of your genome. Does this make sense to you guys? Right. But obviously, the problem here is computation. The computation is huge, right? just even given a one sequence, what you need to do here is you have to start from the head of the reference genome one by one and trying to match all these 6 billion subsequences on the reference genome, right? Until you hit this right target, right? But and even for one sequence, and each time so you cannot do this exact match because look at this case, they are not exact match. They have some difference there, right? And you have to calculate the added distance, unfortunately. Yeah, and you have 10 million short sequence at the very least. So you can imagine the amount of computation you need to put there is on the order of 10 to 15. It's a huge amount of computation. And and these things then become increasingly hard to be afforded by today's, conventional computing resource, particularly those within individual organization, right? At IU, using big computers, maybe you can align, a small set of people's DNA, but and when a number of people increased, you may not be able to handle it. So when this happens, and you may want to resort to cloud and for help, and cloud is, in my opinion, is maybe the only solution because it's a kind of big collection for all kinds of computing resources you can imagine, right? Use all kinds of resources at your disposal and help you to solve the problem in the most effective way. But the problem is privacy. You cannot simply give those DNA sequences to the cloud. Why? Because a lot of sequences come from clinical study. So if if you identify, the owner of that DNA, in many cases, and this guy has certain disease, right? So what can we do? We can remove those identifiers, just like all this metadata, just like and a name, social security number, whatever information. We can remove it from the DNA sequence. Just sequence, nothing more than data. I just give it to the cloud. That this work? Unfortunately, it doesn't work. Why? Because DNA sequence is the ultimate identifier, right? You look at this sequence, you look carefully, you may figure out how this guy looks like, and this guy's skin color, hair color, and whatever things, and just like and you have a high resolution picture attached to the sequence, right? You have such a picture attached to each sequence, even if you don't have the name there, people can still find you, right? It's no good idea. So actually, just National Institute of Health and find this is such a big liability. So today they don't allow anyone to ship those DNA sequence, raw DNA sequence to the cloud, even if you want to take advantage of a cloud computing resource.